Well, hi everybody. Let's continue with this General Electric farm radio, and let me correct something. I said that they called these farm radios because the farmer could take them out to the barn where there was no electricity. Boy, it just shows you how I take electricity for granted. No, they would use these in their farmhouses where they had no electricity yet. So have to think about that a little bit. This radio, I think, is from it's from the 40s. There are farms with no electricity in the 40s. Wow. So last time we tried operating this, we got no sound out of it. Left me wondering a number of things. A, was I doing it right? B, were these tubes actually heating up? And 3, what else could I try? So, not too many answers to that. I also, embarrassingly enough, I left the radio switched on, the battery that's powering the filaments still connected, and to my horror, I left my 90-volt supply running here. This is an admission. Left it running for 3 or 4 hours unattended in my shop. Shame, shame, shame on me. But who isn't being distracted by life these days? It seems like you can't think about the same thing for much longer than about a minute before something distracts you. At least that's my that's my experience. So nothing bad happened, and here we are. So I've already put another battery on here. Let's check it and see if there's some juice left in it. Now, it's very unusual to power vacuum tube filaments. Yeah, it's all there. 1.54 is the voltage on this battery. Very unusual to power filaments. These are low voltage, low current, low power tubes. They take very little power. I guess we could calculate it out. It was 50 milliamps at 1.5 volts. So, you know, I think you're talking about milliwatts of power, which is very, very low. And I don't see any reason why we wouldn't just test the whole thing again, turn it back on, and operate it. We want to know for sure that this guy is supplying power. I'm going to tip the radio up. There. Like that. You know, as soon as I tip it up again, this yellow capacitor comes leaping out here. It certainly looks like a replacement. But nothing else looks replaced. Let me get the B+ supply here. And if I remember all the logic, this was ground down in here, and the plus side is going here. So the way we're going to check to make sure that this battery is conveying current into these tubes is we'll look for the voltage to drop on the battery as soon as we switch it on. And I can do that right now. There, you can let you see that too. Okay, so the battery is reading 1.54 volts, just over 1.5 volts. Turn the set on. And now it's reading oops, double, triple oops. What happened? There we are. Whoa. What's going on there? There we are. 1.3 volts. Turn it off. Should see it go back up. 1.5. So there's no question the battery is supplying some number of tubes. I tested all the tubes, by the way. They were all good. They all tested very good, in fact, which is a great thing. So, okay, so I believe the heaters are operating. That's not the problem. The B+ supply. Turn on my supply here. And we'll make sure it's running around 90 volts. I suppose it doesn't have to be exactly 90. It could be 110. Could probably be 70s or even 60 maybe and still operate. Would be interesting to find out. Put my voltmeter here again. I'm on the 200 volt scale now. Okay, so we're going to apply the voltage. What was that? I heard a funny little sound just now from over here somewhere. Okay, don't know what that was. So we're cranking out somewhere around 100 volts on this. Let's take a look and see what it actually is. It's actually a lot lower than what my meter says, 82. So we'll leave it at 82. 82 should be sufficient. Now, I think I'm looking at a short circuit here. That's pretty unusual. Have a look at this. Yeah, I'll put the supply on standby here. But, okay, so this is what my eye just caught. So I see this rather blobbed up solder job here on this capacitor. And this wire running across here to this terminal, which carries on to ground. It really looks like it's in contact right there. What makes this thing? I gotta learn what makes this camera focus here because it's tricky. There we are. Oh. Well, you can see what I'm getting at. So I'm going to test that with the ohm meter first and see if that really is a short or not. But it sure looks like one. That would be curious, wouldn't it? Huh. How do you like that? There's a short circuit right in here. Right now. Wow, you know, that's short. You know, that looks like something that was done at the time it was installed, or this connection was messed around with. I don't know why it would be messed around. Somebody replaced these wires at one point? Sure doesn't look like it. But this is a little sloppy on the soldering job. Isn't that something? Now you know what else? There's no other connection to that pin, so we better just investigate this a little bit further before I make a silly mistake. I mean, maybe that's supposed to be like that. So what tube are we looking at? We're looking at... We are looking from above. This would be the bottom front. It's not matching up very well. What's going on here? What's happening? Let's see. diagram fits like this. 1, 2, 3 tubes at the back. Oh, way down there. Okay, so it's this tube. It's the IC5, which I believe is the output tube. I think. 1C5. Did I say IC5? 1C5. So let's check that out in my book here. 1C5 power pentode. Output stage of battery operated receivers. Pin number 1 may be omitted. Mounted in any position. Yeah, this is the one that takes the 100 milliamps. It takes heats up hotter. This has a lot of work to do. It's going to drive a speaker. Okay, so which pin are we talking about now? We're talking about pin number 8. 1, 2, 3, 4, 5, 6, 7, 8. I like that. Pin number 8 has no connection. Pin number 1 may be omitted. No, there's a pin 1. So as far as I can tell, pin 8, it just doesn't connect to anything at all. If I got this right, 1C5, pin number 8. Yeah, so the short means nothing. Maybe the guy who was building this knew that. Just didn't care. Or, you know, there was no consequence to having it happen, so it never came up on any technician's radar that something funny was happening, because nothing funny's happening. Came up on my eyeball radar. And we should pull that off. We'll just leave it. We'll just leave it as is. So I think we're all connected now. Let's put the 90 back on. Okay, we're ready to turn on the set and see what we get. Here we go. Well, I gotta let you watch this. I should have let you watch this when I did it just now. Shame on me. Okay, so this is the current meter that's going to read the current flow out of the power supply and into the B plus circuits inside. There's the voltmeter there. Put a little more light on it here. Yeah. Too much light. Okay, so watch this current meter. When I turn the set on, it's going to do a couple funny things. It's going to jump up, down, sort of. Here we go. There we go. So what you saw was the first initial jump was a huge current rushing to charge the battery, the capacitors in the circuit. You saw it drop right to 0. A good sign. And then rise up again. The next rise, which is where it is right now, is the current flow through the tubes. The plate current, which can only flow once the heaters heat up. But on these tubes, the heaters heat up in a fraction of a second. This is almost like instant on. So the current's quite stable. So I think this set should be working. We should hear something now. Some sound, something coming out of the speaker. Ow! Oh. I don't know. I'll put this up here, but it could be some weird magnetic effects that might happen. I'm not sure what you're going to hear now, but there is a little noise there. That's just what we wanted. A little noise. Now, we're going to put on an antenna. It might actually be better to use the signal generator. Let's do that, because we already tried the antenna before and we got nowhere. So we'll stick a little signal into it here. Okay, so this first signal is a radio type signal around 1060 on the AM band. Now, who's the antenna here? Okay, so the antenna is the light wire. That's what you would normally expect. I'll just wrap it around like that. That should supply enough signal from my signal generator to be picked up. So, volume is max. We'll make sure this is about in the middle. That's about the middle. And we'll change the frequency of the signal generator. You can see the numbers there, the 1060. Just looking for any sound of this signal going by. And I don't hear a thing. Now I got my furnace running right behind me here, so it's a little noisy in the shop. Let me stick my ear right down there. You know, there's not a hint of sound there. So let's take it down to the IF frequency of 460, I think it was. And once again, we'll see if we can hear anything at all. Okay, I can hear something. Let's see if you can hear it. Now I got you pretty much sticking your nose right in the speaker here. Listen carefully now. What happened? The whole radio went quiet there. My heater battery's given out. It's coming back. Well, I hope you heard that. For a brief moment you could hear the signal generator and you could hear the tone in the signal generator even. So that's a very good sign. It's very faint. And the radio appears to be going up and down in its ability to receive very slowly. And you don't have much idea what that might be. That's kind of interesting too. Have a look at this. Watch the current flow very carefully on this meter. Go down. It's coming up. Going back down. And it's coming up a hair's width. So there's something unusual going on in there. All those in favor of blaming it on a capacitor. Well, let's see. That's, you know, I can blindly blame that on a capacitor. But I think it's more likely a tube that's not behaving so well. Let's see what's left of this 1.5 volt battery here, which, you know, this may have been a piece of junk battery. With no load, it'll still read a pretty good voltage, but you put a load on these bad batteries and they give up the ghost pretty quick. Let's see where we're at with it here. Right. Oh, I saw 1.3. I get such a hard time making connections to this battery. 1.3, so it's holding in there. I'd rather have it 1.5, but 1.3 doesn't explain anything really. And the output of that battery is not going to go up and down. I have some trouble believing that. Very interesting. When I put my ear to the speaker, and when the output appeared, and it's still playing the tone out of my signal generator up here, I looked over at the current meter, and sure enough, there was more current. I'm sure it's plate current flowing. So I'm going to guess it's a tube. Tube poorly connected, like bad in the socket. It's not so likely. I seldom have had socket problems. Once you wiggle the tube, take it out, put it in, usually the connections are pretty good after that. And there's nothing sudden about this change. It's very slow change. I might have to put all the tubes through the tube tester again and try to spot the one. You know what, I'm also going to read the voltage on this battery just to convince myself that it's not going up and down. I can't see how it could, but even though I've never been wrong about anything in my life, this might be the first thing, so I better check it. Let's see. If you've watched enough of my videos, you know I like to experiment. My aim often, okay, I'm looking right at the voltage here, 1311, 1.311, 1.310. So it's just going down ever so slowly, as you would imagine. 1.309. Yeah, it's just slowly going down. Nothing surprising there. Yeah, I was saying, if you've been watching my videos, you know I like to take a little bit more of an experimental, investigative approach to things. I like to understand what's happening. Fixing them is great, but what I'm often more interested in is trying to figure out what the heck is going on. And what the heck is going on? Now, boy oh boy, this is probably a tube problem. I'm not sure how to approach this. I mean, I could do the wholesale capacitor thing. 1, 2, 3, 4, 5, 6, 7 capacitors, something like that. These ones are probably good. I mean, they all look pretty good. How else could I isolate the kind of problem? Well, I could look for a fluctuating voltage. You know, I could look for a fluctuating voltage throughout the radio and see if I can find something going up and down. I'm looking at the current meter again on the supply, and it's looking pretty steady now. Very low though. It's about half, maybe even less than half of the maximum B+ current that I saw on the meter. So the suggestion here is one or more of these tubes is just not conducting. Let's check the voltage on the B+ again, which should be kicking around 80, something like that. '73, '74. So Could that be too low? Could it be that it's just too low? It really does need to be 90? That's possible. So it's 76. Let's take it up a little higher. Let's see what that is. Okay, so we're right around 90 now for sure. Now let's think about this. The output is very, very low. So why don't we fiddle with the grid on the output tube and see if we can hear that properly. That'll tell us if the output tube is outputting. That was a 1C5. So we'll look it up again. 1C5. Oh! Yeah, it just kind of jumped up there. I could hear it sitting back here for a moment. The grid is pin number 5 on that tube. So we count 1, 2, 3, 4. This is the grid here. Didn't hear a thing tapping it. Let's check for voltage on it. Should show a slight negative voltage or 0, something like that. Ooh, it's quite a high voltage on it. Positive voltage. 2.2 volts positive. Now is that the grid for sure? 1, 2, 3, 4, 5. That's definitely the grid. 2.2 volts positive. Don't think you ever want a positive voltage on the grid. Let's just see what the book says here. 1C5. Grid number 1 volts minus 7.5. Peak audio on the grid 7.5 volts. And that's easy to understand. If you've got minus 7.5, then the most you can put on signal wise is plus 7.5, and that would take you back to 0, never going positive. Okay, so why is the grid gone positive on this tube, which incidentally would normally cause a pretty heavy current through the tube. So here it is here. Well, there's a blocking capacitor right there, and it's probably leaky. Leaky. Let's see. Can we spot that blocking capacitor down there? Yeah, I see it. It's way back in there. Let's see if you can see it on camera or not. I'm touching it with my probe. No, it's a little low. It's behind this connector. Okay, so clearly it's capacitor time. We'll shut off the B plus power supply. And we'll shut off the radio. And then to preserve my little battery, just to make absolutely sure, we'll disconnect it here. We don't need this antenna or signal generator lead. See if we can turn the radio right upside down here. And I think we can prop it up like that. Ooh, that's not so good. And if we prop it up like that, not so good either. We need some better propping blocks here. There we go. And I'm going to spin it around so it tips forward. I can see in it easier. All these stiff wires. There we go. That's pretty good. Gives you a pretty good view into it also. Now, of course, the capacitor I'm going after is kind of buried down in there. So let's just take a look. Here's the grid terminal right here, which you can't see. Let's see if I can get you hanging from above here. That's kind of crummy, eh? Boy, look at that screen. I'm going to fall right over. Funny angle. Okay, could try this again. My pocket camera. I'll try my best not to breathe on the microphone. Well, let's try that. Okay, now what we're looking for is down in here. Right down here. Right on this connection here. And the capacitor is kind of jammed back in here. Let's snip it out of there. I apologize for the camera if it goes a little wonky, because even though I have the screen right here for me to see, I still have to look at what I'm doing. I can't always be looking up at the screen. Okay, sounded like I cut it. Oh yeah. Let's get it out of there. I'm going to cut the other lead too. I'll leave a piece hanging there. Okay. Now how am I going to get that capacitor out of there, for crying out loud? Sometimes you kind of have to map out the whole job, you know. Or you're going to get caught in jackpots, and what I mean by that is, you know, that's a lineman term, at least up here in Ontario. And a jackpot is a bad situation you made for yourself, usually leading to an injury. So there it is. You know, as capacitors go, it looks fairly okay. Let's put the ohm meter on it. See what we get. $20 megohm scale. There we go. See anything at all there. I don't get that. It seems to be good. Oh, there we go. 30 meg, you know, this is a very high resistance here. 36 megohms. Well, 0.01. Let's get another one here. 0.01. Okay, here's a 0.01. Yep. Just for comparison, the last one read 30 something megohms. This camera is not staying where I need it to stay. There we go. And you see that, oop, that was me touching my finger. touch my finger for a moment. So it's off the scale at 200 megohms. That's what a good capacitor should be. Should basically be pretty much an open circuit. So we'll put this guy in. It's possible that other one was leaking enough to put a charge on the grid. Now, grids usually have leak capacitors, or leak resistors on them. Here's one here. See, a leak resistor is 22 megohms. That's interesting, because if this is this capacitor here, right here, so there's a 22 megohm leaking resistor. Leak any charge off the grid. But if this capacitor is in fact also a resistor, 36 ohms, 36 megohms, this thing becomes a voltage divider. You'd actually expect the grid to go even a lot higher yet in voltage. Well, anyway, what I expect doesn't matter. Now I'm gonna, I better put a little hose on this. Where's my hose? As you know, I rearranged my shop a little bit, so now I spend more time looking for stuff that I have cleverly put away. Cleverly put away my little spaghetti. Oh wait a minute, didn't I hang it up or something like that? What was I doing with it? Because I have a lot of trouble storing this wire tubing. It's really awkward, and I thought I hung a piece up or something stupid like that. But,